Hello everyone. Today we will be diving deeper into Flutter, Google's powerful UI toolkit. We are not just going to skim through the surface, we will really explore the technical underpinnings that make Flutter so efficient and versatile. We will understand why it is becoming a leading choice for cross-platform development. So let's get started. Flutter is at its core promise build once, deploy anywhere is a game changer. Think about it. You write Dart code just once and Flutter compiles into native code for iOS, Android, web and desktop. This isn't just a claim, it's achieved through Flutter's unique architecture. We build user interfaces declaratively using widgets. You think widgets are like reusable UI components. You can imagine them as building blocks. Everything in Flutter is a widget, from buttons to entire screen. This widget-centric approach allows for incredibly customizable and consistent UI across platforms. And the declarative nature of Flutter, it means that you describe what the UI should look like and the Flutter handles the how of rendering it. This makes your UI code more predictable, easier to maintain, and frankly a lot less headache. Let's talk about the performance. Flutter's performance is truly exceptional, and that's largely due to Dart's ahead of time compilation. Unlike just-in-time compilation, AOT translates Dart code into native machine code both for ARM or Intel processors before runtime. This eliminates runtime interpretation overhead, making your application run much faster. Impeller, Flutter's new rendering engine, takes this even further. It pre-compiles shaders at build time, eliminating runtime shader compilation jank. This means smoother and more predictable animations. And let's not forget about hot reload. This feature injects code changes into the running Dart virtual machine or VM without restarting the app, preserving the app state. It does this by comparing the new widget tree with the old one and applying the necessary changes. Hot restart on the other hand performs a full VM restart but keeps the native state, useful for changing changes affecting initial app state. It's a huge time saver. Now let's look at some of the key features of Flutter's. Flutter widget system is incredibly flexible. Widgets are immutable descriptions of UI elements. The Flutter framework maintains an element tree, a mutable representation of the widget tree. This element tree manages the lifecycle of widgets and updates the UI. We have stateless widgets for static UI and stateful widgets for dynamic elements. Stateful widgets have an associated state object that manages the widget's state and trigger rebuilds. Now you can create custom widgets by extending the existing widget classes or by creating custom render objects for fine-grained control over rendering. For complex application, state management solutions like Provider, Riverpod, or Block are essential. Provider, for example, is a wrapper around inherited widget, simplifying state propagation. Riverpod uses code generation for enhanced type safety and performance, while Block uses Stream for reactive state management. Each offer different approaches, allowing developers to choose what best fit for their project. Now let's talk about Dart. Flutter uses Dart, a modern object-oriented language designed for client-side development. Dart is statically typed, meaning variable types are checked at compile time, reducing runtime errors. Null safety introduced in Dart 2.12 eliminate null pointer exception by requiring explicit handling of nullable types. Dart async and wait keywords simplify asynchronous programming, make it easier to handle network requests and other long-running tasks. Dart uses isolates for concurrency. Isolates are independent execution units that don't share memory, preventing race conditions. They communicate via message passing, making them ideal for offloading heavy computations. Dart event loop model ensures that asynchronous operations are handled effectively, keeping the UI responsive. In terms of the Flutter's architecture, it is built around three core trees: the widget tree, the element tree, and the render tree. The widget tree is the declarative representation of the UI. The element tree is a mutable representation that manages the lifecycle of widgets. The render tree handles layout and the painting of the UI. Flutter's engine, which is written in C++, uses Impeller to render UI directly onto the screen, ensuring consistent performance. Platform channels allow Dart code to communicate with native platform code, enabling access to device-specific features. And build context is handled to the location of widget in the widget tree, allowing widgets to access information about their ancestor. This is very important for theming and styling of the code and accessing data up the widget tree. Impeller is the Flutter's new rendering engine replacing Skia. Impeller's pre-compiled shaders at build time, eliminating runtime shader compilation jank. leading to smoother animations. It leverages hardware acceleration using modern graphics API like Metal on iOS and Vulkan on Android. The rendering process involves the building phase, creating the widget tree, the layout phase, laying out the render tree, the paint phase, painting the render tree, the composition phase in which it combines different layers, and the rasterization phase which display the final image. Impeller's architecture allow for better control over rendering and making custom shaders more predictable and efficient. This is a big step forward for Flutter's graphical capabilities. As we know, in modern software development, testing is crucial for ensuring application quality. Flutters provide unit, widget, and integration test. Unit test verify individual code units, widget test verify UI behavior, and integration test verify the interaction between components. Test-driven development or TDD help ensure code quality and testability. Code coverage tools help identify untested code for deployment. Flutter uses Xcode for iOS and Gradle for Android. Code signing is required for distributing apps to the App Store and the Google Play Store. Continuous integration and continuous deployment tools automate the build, test, and deployment process. Performance optimization is done using Flutter's dev tools, which provide tools for profiling CPU usage, memory allocation, and rendering performance. Techniques include minimizing widgets rebuilds, offloading computation to isolates, optimizing image, and using lazy reloading. These are all vital for a great user experience. Now, if you want to go and learn Flutter, Flutter.dev and Tart.dev are essential. Flutter.dev provides API documentation, tutorials, and a cookbook. Dart.dev offer language guides and library documentation. Online courses on platforms like Udemy, Coursera, and YouTube provide structured learning. The Flutter community on GitHub, Stack Overflow, Reddit, Discord, and Twitter is very active. Contributing to open source Flutter projects help you learn and contribute to the community. Flutter events and conferences like Google I/O and Flutter Forward provide opportunities to learn from experts and network with other developers. There is very robust and helpful community surrounding Flutter. Now let's talk about the future of the Flutter. Flutter roadmap include continuous improvement to Impeller, expanding web and desktop support, and venturing into embedded systems. Impeller enhancement focus on performance and platform support, web and desktop improvements which are aimed for production-ready applications. Embedded system integration aims to bring Flutter to IoT devices. Tooling improvement like Flutter Dev tool enhancements focus on profiling and debugging. Dart language evolution ensure continued performance and feature improvements. Flutter ability to help build cross-platform application with a single code base is revolutionizing the UI developments. Its developer gains productivity, enhanced user experience, and democratization of the app development make it a compelling choice. So let's start exploring Flutter and join the vibrant community now. I bet you won't regret it. Thank you.